All right, I've got two triangles right here. What does it look like they are to each other, just by looks? Looks like they're congruent, okay? You don't know that for sure, though, do you? No. What's that? You don't think? You don't think? Equal? We don't say equal anyway. We don't say congruent. We don't say triangles are equal. We say they're either congruent or not congruent. Um, yeah, we're not really sure if they are. Now, what if I said this? What if I said triangle ABC is congruent to triangle DEF? Now, are they congruent? Yes, they are. Okay, if they tell you that these triangles are congruent, we just have to believe them that yes, they are congruent to each other, and they definitely are. Okay, even in real life, they're congruent because I copied and pasted. They're exactly the same size. Okay, so you don't believe me? Watch. Look. Look at that. Are they congruent? Yes, they are. Okay, they are congruent to each other. That fit perfectly right on top of this, so they are congruent to each other. Shh. So if I know the triangles are congruent, I basically know 6 things. You just finished going over a worksheet. We just finished going over a worksheet that we wrote out all 6 things, didn't we? So if I asked you to do that again, what would you say? You would say angle A equals angle D, angle B equals angle E, angle C equals angle F. Now that's 3 things. What about the other 3? Angle AB, line segment AB, right, DE, and then AC, line segment AC equals what? Line segment DF, and then line segment BC equals line segment EF. Good. That's 6 things, isn't it? 6 things in order to show that triangles are congruent to each other. But guess what? They're going to actually give you some shortcuts. If we knew this, here's the first thing we're going to do. You don't necessarily have to know all 6 things. All right, you can actually, they actually cut it in half, that you don't have to know all 6 things. If I knew that this side right here was equal to this side right here, all right, now right now I don't know they're congruent, all right, oops, get that squiggly stuff out of there. Right now I don't know they're congruent, but I do know that AB equals DE, all right. I also know that AC equals DF, and I also know that BC equals EF. I don't know anything about the angles, do I? I don't know anything about the angles. All I know is, look, the corresponding sides are all equal to each other. So this side equals this side. You got it? So that's one pair of sides. These 2 sides equal each other. That's a second pair of sides. With me? And then this third side is equal to each other as well. So that's 3 pair of sides that are equal to each other. That's really all I need to know. Dion, you with me? Dion, do you need to sit in a regular chair? Okay, if you can't handle comfy chairs, you got to sit up. Thank you. Watch, all I have to show are that the 3 sides are equal to each other. And then I can say that these are congruent triangles. Okay, that's actually, let me see, 4. Yep, it's actually called a postulate. Have I talked about that before? I think I've mentioned postulate versus a theorem. A postulate is something that you just accept as fact. You don't have to prove it. Nobody has to explain to you, why it is. Postulate is just an accepted fact. And so this first thing right here is just an accepted fact. If you're sitting there, all right, Mr. Hammer, just prove it to me. Well, you actually could. You could demonstrate, not really prove, but you could demonstrate to somebody that this is true. If I gave you 3 lengths, let's say like toothpicks or something like that, or straws or something, okay? And I gave you 1 length, and then let's see, I gave Brittany the same length, okay? So I've got 1 length straw, she's got 1. Then I take another length of a straw, and I give her the same exact length. Then I take a 3rd length of a straw, and I give her the 3rd length. And I said, okay, put together a triangle. I was like, okay, so I'm taking my 3 lengths, she's taking the same 3 lengths, and she's putting them together. She's making a triangle out of it. Are you listening? And then I make a triangle out of mine. Is my triangle going to look any different than her triangle? It's going to look exactly the same. All right, that means that if I have 3 sides of one triangle equaling 3 sides of another triangle, then those 2 triangles are now congruent. And we call that side, what do you think? Side, side. All right? So this represents one side. This side right here represents the second one. This one represents the third one. It's side, side, side. It's a postulate. Yep, we actually call it the side, side, side postulate. Now, to make it a little easier, instead of writing the word side 3 times, they make it a little easier for you and just say SSS, okay? But we don't say, listen to me very carefully, we don't say SSS. What do we say? I'll put it in quotes. Right, we put it in quotes. We say side, side, side. So I'll put, we say this, but we write SSS. You with me on that? So if I asked you, why are these triangles congruent to each other, if I'm given all that, you write SSS, but if I ask you verbally, what would you tell me? You'd say side, side, side. Okay? That's a postulate. It's accepted without proof. All right? It's something that they just tell us is true, and it works. Try that sometime. Take, I don't know, take a straw or a toothpick or, I don't know, what else you could, use to measure things, but take three sides, and you take those 3 sides, take the exact same 3 sides, give it to somebody else, and tell them, you make a triangle, I make a triangle. You make the triangle, you'll make it exactly like the other person will make that triangle. Okay, that means those 2 triangles will be congruent to each other. Does that make sense to you? All right, that's a reason. It's side, side, side. Let's do another one. All right, now I've got 2 different triangles. Now, I just made them obtuse just for fun, just to make it different than what the other triangles look like. This doesn't have to be obtuse. The other ones didn't have to be acute. All right, I just changed it. It could be any kind of triangle, I'll tell you the truth. But watch what I have. I haven't told you anything about these triangles, have I? But what if I told you that this side was equal to this side right here? Is that enough to say the triangles are congruent? No. What if I said that this side was equal to this side? Is that enough to show the triangles are congruent? No. All right. Now, if I told you, I'm not going to, but if I told you SH was equal to EC, would that be enough to say the triangles are congruent? Yeah, for what reason? Side, side, side. That's right. Okay, if I know that all 3 sides of this triangle are equal to all 3 sides of this triangle, that's enough. I don't have to know anything about the angles. I know that those 2 triangles are going to be congruent to each other. You with me? But I don't know. For some reason, they don't tell you that SH equals EC. But they do tell you this. They do tell you that angle D equals angle B. Now again, this is another postulate. This is something that you can't really prove, but you could kind of demonstrate. If I gave you one length of straw and another length of straw, and I said, okay, make a triangle, but the angle between those 2 lengths of straws has to be, I don't know, 30 degrees. All right? So, Brooke, I give you 2 pieces of straw, the same length as my 2 pieces of straw. And I say, all right, the length between those 2 angles has to be 20 degrees. And the length between my 2 pieces of straw has to be, not the length, the measurement of the angle between my 2 pieces of straw has to be 20 degrees as well. And I'm like, okay, take my straw, take the other straw, make sure it's 20 degrees, and then what's going to be true about the 3rd side? This triangle will look exactly like this triangle right here. Okay, it won't look any different. There's no way you can make it any different. If I give you one length and I give you a second length and I said the angle between them, all right, not just these angles, the angle between these 2 sides have to be exactly the same. Is there any way you could draw a different triangle? There's not. Because look, if I took this side and made it go way out here, what did I just do? I just changed that angle, didn't I? What if I took this and said, well, make this longer? Well, yeah, but it's not the same side as this. There's no way that you could draw a different triangle given that amount of information. All right? Those 2 triangles will look exactly the same. Okay? That means what's true about those triangles? They are what? They're congruent to each other. Now let's think of a name for it.
Angle.
Do I know these? Do I know these? Think before you speak. Okay, that's a good guess, but it's not side angle. It's side, then an angle in between them, and then a side. All right. So we say, watch. How do we say it? We say side, angle, side. But when we write it down, what do you think we write down? Right. Side, angle, side, like that. Okay? Just like that. So if you write it down, so if I say, what is the reason that these 2 triangles are congruent to each other? What would you write? SAS. That's a weird looking S, doesn't it? All right. And then if I ask you to tell me verbally what's the reason you would say side angle side? Notice what's true about the angle. I kept on saying this. The angle is in between those two sides. But in geometry, we don't say it's the angle in between. We say it's the included angle. All right? The included angle. What does that mean? That means it's between the two sides. You see me? You see what I'm saying? Okay, it's between the two sides, and that's called the included angle. Make sense? All right. Probably asking, what in the world are we going to do with this stuff? Well, I'm glad you asked. See, I knew you were going to ask that. Actually, let's do this. Let's do a quick example. We've got a couple minutes here. Here's an example of what we're going to do today. So you guys, make sure you go on YouTube and watch what we're doing here, because this is going to help you with the... and you've got to take a worksheet, too. Here you go. I'm going to explain a little bit on here what to do on this worksheet, so listen. Okay, guys, listen up. Shh, we're not finished.
Both sides? Both sides?
Yes. All right, let's pay attention. Come on, we're not done. Rayvon, have a seat. Don't just get up in the middle when I'm doing something here. Let's see. This is what they're going to do. Let me find a good example here. But yeah, I'll do the one in the book because I'm giving you the worksheet anyway, right? So here's an example. I'm going to give you a bunch of points here. So write this down. Write this down. Just write it down. This is an example. Okay, right there. I said it already. It's an example. Scrap, please stop. Thank you. And then S. It's a Q. All right, there we go. What it's going to say is going to say determine whether these triangles are congruent. It says determine whether triangle MNO is congruent to, watch, I'm going to put a little question mark over it. Okay, we don't know yet. We don't know they're congruent. We're trying to figure out, are they congruent or not? Columns. They're ordered pairs. All right, so we're trying to figure out if triangle MNO is congruent to triangle QRS. Let's just think about the first postulate that we learned. What was that? Side, side, side. That means if all three sides of this triangle are equal to all three sides of this triangle, then they're congruent, right? So guess what we have to do? Lots of distance formula stuff, okay? But look, you should be used to this by now, okay? Let's not freak out over distance formula. It's not that hard, okay? It's pretty quick. It's pretty easy. So what do? We take line MN, right? And we see if it's equal to line QR, all right? So let's do that. So the distance of MN, and then we'll do the distance of QR. I'm not going to do all of these because we're running out of time, but you get the idea, right? Yeah. So let's do this. Let's find MN. So the distance equals, it's a big square root, right? And then it doesn't matter which ones go first. But what do? We take the x's and we do what with them? Let's just do this in our head. We subtract them. 5 minus 2 is 3. And then what's this? This is another 5 minus 2, which is 3. You with me? So that's 9 plus 9, which is 18, so square root of 18. Let's see if QR is the same thing. If it is, we know those two sides are equal to each other, right? Yep. And so let's do that. Put a parentheses squared, parentheses squared. See how easy the distance formula is once you know what you're doing? Yep. Watch. Subtract the x's. Now this one's got some negatives, so it's a little bit tougher, but how do you want to do it? Negative 4 minus negative 7, which is the same as plus 7, right? Which is 3. Let's do the y's. 4 minus 1, which is 3. So that's 3 squared, which is 9. That's 3 squared, which is 9. And guess what? It's square root of 18. So is MN equal to QR? Yes, it is. So that's one set of sides. Then you got to do the same exact thing for what? NR I'm sorry, NO and RS, see if they're equal to each other. And then you do the same thing with MO and what? QS. Do you see that? Ooh, I better hurry. All right, so that's it. Have fun.